A very good afternoon and welcome to our today's lesson. And we want to look at friction. Now, in our last lesson, we looked at how friction interacts with other forces to disturb or ensure the balance of a body. And right now, we want to understand what friction is and probably look at a few types of friction that we have. I will start by defining friction. And friction is the force. It is the force that opposes. It is a force that opposes relative motion between two surfaces in contact. It is a force that opposes relative motion between two surfaces that are actually in contact. That is to mean that if bodies are not in contact, then we cannot claim to have friction working between the bodies. They have to be in contact, and then they have to be in motion. Those are the two important aspects of this definition that you have to put in mind. Now, friction is of different kinds. And we have about 4 types of friction. One is what we call static friction. We have sliding friction. We have rolling friction. And lastly, we have fluid friction, which is also called the viscosity. It's also referred to as viscosity. That friction can be classified into 4 different types of friction. Now, depending on how it is applied or where it is applied, we can come up with these 4 types of friction. Now, let us look at each one of them and see how different it is from the others. We start with what we call the static friction. And the static friction is the friction. It is the type of friction that acts on surfaces at rest. Now, you could apply some force to an object. You could apply some force to an object that is at rest and make sure that the force is not enough to trigger motion of that particular surface. Now, that is not to mean that the force is negligible, and that is not to mean that the force actually does not act on the surfaces. What it means is that the amount of friction that opposes the force that you are applying on the object is more than what you are applying, and therefore the force applied is less than friction. That is why your object does not move, although you have applied some force to it. Now, the second type of friction that we have is what we've called the sliding friction. And sliding friction is actually the friction sliding friction occurs between objects. It is actually the type of friction that occurs between surfaces that are sliding. It is the friction that occurs between surfaces that are sliding over each other. Now, for example, we look at our object again and we try to apply a force that is just enough to make our block slide on the book. Now, the fact that the box is sliding does not mean that there is no friction between the surfaces. What it means is that the friction between the surfaces is actually less than the applied force, and the resultant net force will result to the movement of the object. Sliding friction, that if you take the applied force and subtract friction, the resultant is actually not zero, and the resultant force is what is going to cause the motion, much as there is that friction that is experienced even when the body is sliding over the other one. The third type of friction, is what we call rolling friction. And just like the name suggests, it acts between bodies, that are rolling over each other. Bodies that are rolling over each other. Take, for example, the ball bearings that you put somewhere between the surfaces of a gear. When they roll, they actually cause some friction between them, although the friction could be either positive or negative. It could either be desirable or undesirable, but the rolling has some friction that is caused by the ball bearings. Now, the fourth and the last type, is what we call the fluid friction. or what we call viscosity. Viscosity, some books will call it viscous drag. Viscous drag. And it is the type that occurs between fluid layers. It is the friction that occurs between fluid layers. You will ask yourself, what is a fluid? And a fluid, I will define it as anything, is anything that can flow. Anything that can flow and that can assume the shape of the container in which it is put. That anything that you can think of that can flow and that can take up the shape of the container in which it is put is what we call a fluid. And in this category, we have two types of fluids. One which we call the liquids, can give examples of liquids, and gases. Gases are also classified as fluids. Now, we have looked at the types of friction that we have in nature, and now we ask ourselves, what affects the amount of friction that is going to be experienced by the two surfaces that are in motion? That brings me to the factors affecting friction. Factors affecting friction. And when we talk about factors affecting friction, we do not single out any type of friction here. We consider all the four types of friction that you could have, and these factors apply in case of the four types of friction. And I have about two. Number one is what we call the nature of the surface. Nature of the surface. And number two is the size of the object. Or if you may, you can talk about the mass or the weight. Now, we shall look at mass and weight and how they are related. But for now, let us look at the factors affecting friction, and mass is one of them. And number one, the nature, when we talk about the nature of the surface, we are actually interested in the roughness or softness of the surfaces. The roughness or softness of the surfaces. And I will point out that depending on how rough or soft the surfaces are, the amount of friction that is going to be experienced is going to differ. And friction in itself is directly proportional. It's directly proportional to the roughness, of the surface. It's actually directly proportional to the roughness of the surface, and that is to mean that you increase the roughness of a surface, you automatically increase the amount of friction that is going to be experienced between the surfaces. Now, how about the size? Size. Number 2 is the size of the body. And size of the body gives us an idea on the normal force that we expect the body to exert. The normal force exerted by the body on the surface. Size of the body translates to mass, and the mass gives us an idea of the normal force that is going to be exerted by this body on the surface in question. Remember, we said that when a body is placed on a surface, it exerts a normal force in whatever direction depending on where the body has been placed. But when you subject this body to a force, let's say an upward force, which I'm going to call the action force, the body exerts an equal but opposite. It exerts an equal but opposite force, which we call the normal. Now, the normal force is directly proportional to the mass. Normal force is directly proportional to the mass of the body. Directly proportional to the mass of the body. And that is why it is very important to take care of the size of the body that is going to be slided or even rolled on the surface, so that we can get an idea of the reaction that we expect from that particular body. Now, the two factors that we have looked at are summed up in an equation that we call the equation of friction. The equation of friction is basically the relationship between friction and the factors, friction and the factors affecting friction. It is basically an equation that relates friction itself and the factors affecting friction. We have looked at these two factors, which is the size or the mass of the body, and we have said that the mass of the body is actually directly proportional to the friction that is going to be exerted on the surface. We also looked at the nature of the surface, and again we said you increase the roughness of the surface, you automatically increase the friction that is going to be experienced between the two surfaces. Now, therefore, suppose we convert mass of the body to weight. We convert mass to weight, which is actually a form of force, and that one is done by multiplying mass and the gravitational force of that particular area, which is actually assumed to be 10 newtons per kg. Therefore, if we want the weight of this particular mass, you will take it to be mass times gravitational force, or simply mg. Now, friction force, I will symbolize it with a capital F and then with a small f as the subscript, and then I will use the proportionality sign and say it is directly proportional to the weight of that particular body. That force of friction, which we are calling capital F with a subscript small f, is directly proportional to the weight. Directly proportional to the weight. And weight, we can use a W or even an N. N for normal force, or simply a W. Now, we want to get rid of that sign, the proportionality sign. Therefore, we are going to introduce a coefficient. We are going to introduce a coefficient so that now we can change the proportionality sign into an equal sign, and that implies that our equation now becomes friction is equal to that is the coefficient, and then the normal. This is the coefficient of friction, and then we have the normal. The coefficient is going to give us an idea on the nature of the surface. Nature of the surface. Now, depending on the nature of the surface, if you increase the roughness, you increase the value of the coefficient, and equally, you smoothen your surface, the coefficient reduces in value. Then the normal gives us the weight, and subsequently we can get the mass of the body. Now, let us say something small about the coefficient. Now, the coefficient of friction, like I have said, gives us an idea on the nature of the surface. Now, it can be of two types. One can be coefficient of static friction, which we are going to symbolize as mu subscript s. And then we have the coefficient of kinetic friction, which again we are going to write as mu and a subscript k. Probably just so you can note, kinetic friction is what we call the sliding friction. So you could call it coefficient of kinetic friction, or better still, the coefficient of sliding friction. But just so that we can bring out that difference, let us use kinetic friction. Now, the coefficient of static friction is considered when bodies are being acted upon, by static friction. On types of friction, we were able to establish that static friction is actually the friction that is experienced between bodies that are not in motion or bodies at rest. Now, if you want to calculate friction, which we called static, that is the friction experienced when you apply a force to a body which is not enough to produce some motion, you will use this particular coefficient, which we are calling the coefficient of static friction. Now, how about the coefficient of kinetic friction? The coefficient of kinetic friction, it is applied when bodies experience kinetic, or what we call sliding friction. When bodies experience sliding friction, or what you call the sliding or the kinetic type of friction. Therefore, when you want to calculate kinetic friction, you give it a subscript k, then you will apply the coefficient of kinetic friction. That one you multiply it by the normal, or what we call the weight. Remember, this one is reached by multiplying mass times gravitational force, which I said should be assumed to be 10 newtons per kg. Let us take an example. Let us take an example where we can apply that particular formula. A crate of soda of mass 15 kgs is dragged on a rough surface if the coefficient of if the coefficient of kinetic friction is 0.5, calculate the friction that acts between the two surfaces. Let us go back to our formula. That kinetic friction is given by the coefficient of kinetic friction, and this one should be multiplied by the normal. Now, ask yourself, what does the question provide? A crate of soda of mass 15 kgs. So mass is 15 kgs. 15 kgs is dragged on a rough surface. If the coefficient of kinetic friction is 0.5, the coefficient is 0.5, then you are expected to calculate the kinetic friction. So this is how you go about it. Go back to the question. You have the coefficient, you have the mass, but you don't have the normal force, or what we call the weight. So the normal is going to be given by mass times gravitational force, and your mass is 15, gravitational force is our kgs. Gravitational force is always 10 newtons per kg. Therefore, you end up with 150 newtons as your weight. Therefore, kinetic friction is going to be given by 150 newtons, and you multiply by the coefficient, and that will give you 75 newtons. Now, one interesting thing you are going to note about the coefficient is that it doesn't have units. Like for example, gravitational force is 10 newtons per kgs. Mass is 10 or 15 or whatever value in kgs. Force, we are measuring it in newtons. How about the coefficient? Now, the coefficient does not have units, and it is because it is a ratio. The coefficient or coefficients of friction do not have units because they represent a ratio. Why do we call it a ratio? Look at, for example, the formula we have just applied, that of kinetic friction. We said is going to be given by its coefficient multiplied by the normal. Now, if you look at the friction in itself is measured in newtons, the coefficient is what we are interested in, and the normal is also measured in newtons. Now, if we make the coefficient the subject, if we make the coefficient the subject of the formula, you will realize that now let me label this equation as equation 1. Now, when we want to make the coefficient the subject of the formula, equation 1 will become, now we will make it the subject of the formula by shifting the normal to the other side. Therefore, we shall have kinetic friction in newtons divided by the normal, again in newtons, and that should give you the coefficient. Now, the units here are the same, which means that the friction and the normal are both forces. Therefore, we are justified to cancel the units, and what we are left with is just the friction force divided by the normal, now minus the units, is what is going to give you the coefficient of friction. Therefore, we have two forces and we are getting their ratio. Therefore, we can cancel the units to come up with the coefficient which does not have units. Now, the same case will apply to the coefficient of static friction. It also doesn't have units. I want to give you an example too. Example 2. A block weighing 200 newtons is pushed along a surface. Is pushed along a surface. Is pushed along a surface. If it takes if it takes a force of 8 newtons to start the block, and 40 newtons to sustain the motion. Calculate coefficient of static friction, and part 2 requires us to calculate the coefficient of kinetic friction. A block weighing 200 newtons is pushed along a surface. If it takes a force of 8 newtons to start the block and 40 newtons to sustain the motion, we are required to calculate the coefficient of static friction as well as that of kinetic friction. Now, from the two formulas we have had, friction is given by the coefficient times the normal. Now, depending on which kind of friction we are after, that is where we shall determine, or that is what will determine the coefficient we are supposed to apply, is given by the kinetic of static friction multiplied by the normal. In this case, static friction is given by 80 newtons. The coefficient is what we are looking for, and the normal is 200 newtons. Therefore, the coefficient of static friction will be given by 80 newtons all over 200 newtons. You can cancel the units, and 80 divided by 200 is 0.4. That is our coefficient of static friction. For the same surface, we want to get the coefficient of kinetic friction, which is given by, we apply now the second equation. Let us substitute for what is available. This one is 40 newtons. This one is what we are looking for. And the normal again is 200 newtons. Therefore, coefficient will be given by 40 over 200 newtons, and the units will again cancel, and you will get it as 0.2. Now, something important that you will realize from the example that we have calculated is that the coefficient of static friction is always greater than that of kinetic friction, and for the same surface, that the coefficient of static friction is greater than that of kinetic friction. That is something that we are going to revisit when we shall be looking at the laws of friction. Let us look at the last example. Example 3. Example 3. A 500 Newton crate. A crate weighing 500 newtons is pulled on a horizontal floor. Is pulled on a horizontal floor. Whose coefficient of kinetic friction is given by 0.1. What is the pulling force? What is the pulling force? Now, let us look at that question. A crate weighing 500 newtons, so the weight is 500 newtons, is pulled on a horizontal floor whose coefficient of kinetic friction is 0.1. Again, we are given the coefficient as 0.1. Then we are required to get the pulling force, which is now our kinetic friction. And we will apply the formula. And we multiply by the normal, which is also the same as the weight. And our kinetic friction is therefore going to be given by 0.1 multiplied by 500 newtons. Again, remember we are calculating a force, and therefore we have to take care of the units. And this one will give us 50 newtons. 50 newtons. Let us look at laws. Laws of friction. Laws of frictions. Laws of friction. And number 1 is that it is dependent on the nature of the surface. Now, when we are discussing the factors affecting friction, we are able to point out that the nature of the surface dictates the amount of friction that is going to be experienced. Number 2, friction is actually dependent on the normal force. Normal force. Again, the normal force is going to be brought about by the weight of the body that you are dealing with. Number 3 is that friction is independent of velocity of motion between surfaces. We have said that friction is experienced by bodies that are in relative motion. Now, when you're talking about friction, velocity with which the bodies are moving is actually immaterial. Number 4 is that friction will not depend on the area of contact. Friction will not depend on the area of contact. If you are dealing with the same surface, the size of the material that is going to be slid on the surface is what dictates the amount of friction and not the area of contact between the two. And lastly, we have noted that the coefficient of kinetic friction is always less than that of static friction. So now, those are the basic laws of friction, and they dictate the manner in which friction operates between surfaces. Now, next time we meet, we will look at applications of friction, which is the last aspect of the topic. That's all for today. Thank you.